I'm going to move on and do the answer to question 7 now. In question 7, we've got a speedboat. I'm going to go back so you can read it really quick. Apologies for all the writing on there. Let me erase that now. Okay. In sample 7, we got a speedboat traveling 30 miles per hour at a compass heading of 100 degrees east of north. I haven't heard that in a long time. The river velocity has a magnitude of 15 miles per hour at a heading of 22 degrees east of north. Find the resultant velocity, which means magnitude and direction, of the boat. Okay, so same steps, but you notice some of the words are a little different here. Do you remember this notation? Do you remember this notation? I think we were using this a lot when we were doing the cell phone triangulation project, if you remember that. So maybe I should just go off to the side for a second and just bring back this diagram that we made. Feel free to write this down in your notes, or you probably still have it already from when we did this in chapter 4. Do you remember? Each of these arrows represents some combination of directions, what we called bearing, or sometimes it's called heading. And it's always start at the second direction and go towards the first direction. For example, this one down here looks like I started south and I'm going to the right, which is east. So this would be east of south, that direction there, because I started south and I'm going to the east. All right, I'm going to fill in one more. I'll fill in this one way over here. Can you figure that one out? See, I'm starting north, I'm going to the west. That means this would be west of north. All right, go ahead and pause the video right now, folks. And if you want to go and plug in all the other 6 degrees and directions, and come back and double check with me just to see what you remember. All right, here we go. I'm just going to start where I left off and just keep going clockwise. This would be east of north. North of, I started east. This would be south of east. I already got east of south. This would be west of south. South of west. And finally, north of west. Okay, folks. How'd you do on that? If you remember that, then the bearing that we're going to do on these word problems are really not that bad. You'll be okay. Okay, let's go back to that problem real quick. Here we go. So now let's take every movement and turn it into a vector like we did in number 6. Let's see, the first direction they tell us. A speedboat is traveling. All right, here's your first movement. 30 miles per hour at a compass heading of 100 degrees east of north. Okay, there's my velocity. That would be my magnitude. And over here would be my direction. But it's a little bit more complicated, so I need to figure out what that means. 100 degrees east of north. I can't plug that into my vector because that's not the true angle. At least I don't think so. Let me go over here and think about it. What is 100 degrees east of north? Okay, it means I'm starting north up here. I'm going to go towards the east. I'm going to go 100 degrees. All right, that means I go, starting from north, I'm going to go east. All right, that's already 90. I need to go 100. So how much more do I have to go? About 10 more degrees. That means my angle is actually right here, folks. And the little reference angle there is 10 degrees. That's 100 degrees east of north. Here's the problem. In order to use angles and direction angles here, folks, you have to always start from 0 and go around counterclockwise like we normally would. So really, how much is that angle? Well, I traveled almost a full circle, but just less 10 degrees. So this would be a full 360 minus 10 is really 350 degrees. So 100 degrees east of north really means 350. Oop, I put 35. 350 degrees. That's what I'll plug in. Let's do that. Okay, so the speedboat, I'll put down here. That vector should be, magnitude was 30 miles per hour. Cosine of the angle, we said 100 degrees east of north is really 350 degrees. And the y, or the vertical component, should be magnitude sine of the direction angle. All right, that's the boat. Again, magnitude, cosine of the direction angle, and then magnitude sine. And we're going to do this every single time. All right, let's take apart the river, because that's the next movement. The river velocity has a magnitude of, I even tell you magnitude, and a heading of 22 degrees east of north. See if you can figure out how many degrees that really is. All right, let's try that over here. Here comes the river. The river is pushing the boat. How so? Okay, the magnitude of the river was 15 miles per hour, cosine of some angle. I'll leave that blank, I'll come back to it. And then the y component would be 15 sine of that same angle. Let's figure out that angle. It was 22 degrees east of north. So on my diagram right here, I'm going east of north. So I'm starting north, and I'm going to the east 22 degrees. Okay, so that's 22. But the 22 is actually here, right? Because that's the angle I made. I need to start from 0. And starting from 0, how much is that real angle? And as you can see, that's a full quadrant, or 90 degrees, minus the 22. And I'll plug that in. That means my angle is really 15 cosine of 68 degrees is the real angle direction that the boat is traveling. Okay, now what we can do is we can take each of these vectors now and find the resultant. So why don't we add it to this one? So what might be easier though is why don't we put each of these into decimal form, and then we can add them together. All right, if I put the boat into decimal form, I'm going to do 30 cosine of 350, and that is about 29.5. I think nearest tenth is fine on all of these folks. And then 30 sine would be negative 5.2. Okay, that's the boat. Let's do the river. So 15 cosine of 68 would give me about 5.6. 15 sine of 68 degrees would be about 13.9. Great. That's each one now in component form. And to find the result, we're just going to add them and find the direction by using the tan inverse and the magnitude using Pythagorean. Good job. I have to end the video before it gets too long, but that's generally how we're going to do each of these problems. Turn every movement into a vector in component form. Good luck with the angles if they're a little tough. And then add them together to get a final resultant vector. Then use Pythag for mag. Use tan inverse direction. Good job, folks.